This session is about the future. Now, it's very hard to predict the future. And I'll give you some examples. We are in France, so I start with Napoleon when he was introduced to steamships. So he said, okay, this would be fields. Heavy and air flying machines are impossible. So, well, there are some things outside that prove the opposite. And even for spaceflight, a rocket will, New York Times, 1936. Anyway, we're going to try to predict the future of human spaceflight. We start in the beginning. Actually, we start with the early future and then we go in the far future. And some of the future started already. I had the pleasure and honor to bird the first Dragon to the space station. Very exciting. And when you open the hatch, I thought it was in a science fiction movie. I thought, oh, this is clearly coming from Hollywood. The future of commercial spaceflight started already with those first flights. And the future will even be more, because if you open the hatch in the future, there will be crew inside. And so that's the first what we want to start with. We have a bright future in commercial transport, and that's why I would like to ask Jeff to be the first speaker to talk about the commercial crew program. Jeff, yes, there you are. So the floor will be yours, and we're all interested in the near future. I'll put it on for you.
Thank you, André. Yeah, I've been asked to give an update. I guess this has been an annual item at the Congress to update the commercial crew program. So I'll give you a few details of what I know, and then maybe some comments on the bigger picture, how I think it fits in. Of course, I think most of you are familiar with the history of the commercial crew program, a very unique procurement, if you will, and development program. Now we're in what we call CCT CAP, which is the fourth phase of the procurement of the program to actually get vehicles flying and on board ISS, and of course that's a SpaceX Dragon and the Boeing CST-100. As you probably know, the CST-100 will launch on an Atlas from Launch Complex 41. They're planning a land landing, and they've got several landing sites in the western part of the U.S. And they're currently targeting their first uncrewed launch in August of next year and the first crewed launch of November of next year. And as you perhaps recall, the plan is for 2 test flights, and then we'll go into post-certification flights, and that'll take the first rotation crews, expedition crews to the ISS, and I'll get back to that here in a minute. SpaceX Crew Dragon launching on a Falcon, and it seems like every Falcon is a unique rocket. They are very aggressive at developing their rocket technology too. So what I have read is that it's going to launch on a version 1.1, launching from 39A, and of course they're planning on going into the water. As opposed to Boeing. And their current target test dates are April and for the uncrewed, and August of next year for the crewed. Let's see, some highlights of recent months of the activities, and you can all find this out on the internet, some of the activities that have been taking place in the development of these vehicles. That would include the spacesuit and life support development and integration, which obviously is a key part of the whole thing for us. And I would say probably still a fair amount of integration to go. There have been some drop tests and parachute testing underway, and there's more coming up in the near future. At Johnson Space Center, we've been a little bit more involved in the training facility development. You may know that Boeing has actually contracted with NASA to provide the training and also the mission operations support using the teams there at Johnson Space Center. Of course, controls and displays have had a lot of ongoing work going on as you get into the final developments of the vehicle and the interaction with the crew members that are working with the contractors. Launch complex development, of course, is in development. We've been spending quite a bit of time now from internal to NASA with the flight operations developing the detailed plans for the pre-launch and post-landing recovery and rescue operations as well. A few words on the integration into the program. This is probably, aside from the development of the vehicles themselves and all the challenges that come along with the development of a new spacecraft, integrating into the ongoing ISS program has also presented some significant challenges and will present some significant challenges. Just a couple weeks ago, we formalized by contract to procure some more Soyuz seats. You might have read or heard about Boeing seats, so-called Boeing seats, and that was a clever procurement of seats through, it had to, I don't know all the details, but it had to do with the history of the old sea launch program and a debt that Energia had incurred with Boeing. So to help pay that debt, NASA procured seats on Soyuz through Boeing, so from Boeing, and then there was I don't know all the details, but you may recall that there were a couple of seats procured about a year ago or so, and they're flying here in the next few months, and there was an option to procure 3 more seats under that agreement, and those were just procured a few weeks ago. And that gives us 1 seat in March of 2019 and 2 seats in May of 2019. So right now we're dependent upon the commercial crew vehicles to continue the rotation to the ISS after that time. And that's the latter part of 19. In terms of the ops concept, the steady state assumption is that right now we have 4 Soyuz vehicles going to ISS every year. So the assumption will be there will be 2 Soyuz vehicles going and 2 commercial crew vehicles replacing what we call the B line, or the summer and the winter. Soyuz will be replaced with a commercial crew vehicle. And the ops concept is to continue to have 1 American on every Soyuz and 1 Russian on every commercial crew vehicle, so that if at some point we have to go down to a crew of 3 or 4 with 1 docked vehicle, we'll always have both sides represented. So we're working through all of that, and there'll be plenty of work to go as we get closer to first launch, post-certification after the test flights, integrating into the plan. Now, I saw on the agenda there was Q&A here. Was that the intent, André?
Apparently there is time.
Huh?
Apparently there is time now.
Yeah. So are there any questions or comments? Because some of you know more about commercial crew than I do. Back here.
Jeff, the arrangement between NASA and the partners, Japan, Canada, and Europe, does it go on, or how do you cope with the new arrangement taking the partner astronauts to the ISS?
Yes, the partnership goes on. In fact, a lot of the integration and dialogue that's going on right now is involving the partners in the certification process. I mean, none of us want to put our crew members on a vehicle that's not certified, right? So, and this is a unique thing, and I think even, NASA's doing this for the first time. So just 3 weeks ago, we had a multilateral crew operations panel, which I currently chair, here in Europe, and much of our 3 days of meetings was spent reviewing how we're sharing data of the vehicles with the partners, so that the partners can have a level of confidence in the process leading to certification of the vehicles to eventually put their crew members on it. As you know, in the ISS program, there's an allocation of days on orbit that each of the partners has, and it's proportional to the contribution to the program, and that's what drives the frequency or the infrequency, in some cases, of partner crew members launching to ISS. That will be integrated also into the commercial crew manifest as well. Now, I will add to that, and this is just kind of speculating on what the future holds. Obviously, this is a very unique point of history of space exploration in that we're learning how to integrate what we're calling commercial activities. And it started out with spaceflight participants, of course, launching on Soyuz, going to ISS for short durations. And now we're procuring the service of a launch vehicle to take us to and from the space station right now with Boeing and SpaceX, and we know there are other players out there as well. We know that there's some discussions about commercializing the space station in general, and some more specific discussions about commercializing parts of the space station or time periods of the space station, or adding to the space station, for example, with a commercial module that would have certain capabilities. So there's a lot of unknowns in the future, but I predict that it will continue to grow, and I think everybody is on board to make it successful with whatever pops up in terms of a commercial entity that has something that's realistic and can be executed. I think it's the inevitable way that we're going to go, and it's probably the way we want to go. So that for a couple of reasons. One, it will allow the government agencies to focus on the exploration beyond Earth orbit that we're always talking about. And personally, my personal belief is it will also solidify the support, if you will, and this would be the international political support to sustain space operations in general, and that's the ISS right now. My personal belief is that if we, for example, terminate the ISS so that we can, in theory, free up the resources to move on to something else, that we set the conditions such that we don't have anybody flying in space, and that at that point it will be very difficult to gain and sustain the political support to start something new, and then we'll have an indefinite gap of no presence in orbit. That's my personal view. Yes, is that Pam?
So Jeff, the current phase of the program is by and for the government, CC CAT during certification, and the first few flights... Microphone. So the first few flights are under NASA's control as a part of the CC-CAT certification process, and then at some point the flights will be commercial services procured. How many flights before you're going into that services contract, and when will that services contract be let and start to be discussed?
Well, as far as I know, the contract right now, and this is a phase, I think it's phase 4 of this procurement, the CCT-CAP, and in that contract, from each of the providers, Boeing and SpaceX, NASA will procure a minimum of 2 rotation flights, post-certification flights, and up to 6. Is that right? There's a couple of folks that know this better than I do historically. Up to 6 flights. So there's a range there. So it depends upon, of course, the performance, the success of each individual program. The theory is, one of the theories I think is that having 2 developments in parallel like this, with this kind of procurement, puts a little bit of competition in the mix, which is good. It also puts some redundancy into the capability. So if one fails, you got a second one that hopefully will succeed. so that we can continue in the short term with the space station program. But my guess is, and I don't know this for a fact, but my guess is then that will follow with another letting of a contract for services. And who knows, it could be another company that gets in the mix too.
For as far as training here, training, where will it take place and for how long?
We're still working our way through that. In fact, that was another major topic of discussion a few weeks ago in the MCOP to talk about crew training. I think it's going to be a mix. It depends upon the provider as well, but it'll be a little bit of a mix at their site. As I understand it, SpaceX right now is wanting a lot of their training out there in California. Boeing, on the other hand, I think will have most of the training in Houston. Of course, there'll be some training at the launch facilities as well. And then it'll have to be integrated with the ISS training that we're already doing.
Jeff, I know when, it was before my time, but when the shuttle was being developed, the crew office had some very different concerns and weighed in on different things in developing the shuttle, etc. Are there any particular technical issues in the certification that the crew office is pushing or working or fighting for, that kind of thing?
There's all kinds of things that everybody's engaged in, to include the crew office as well as the rest of the organizations out there that normally are involved in a development process like this. It's a little bit different here. In the past, we have been we let a contract to develop a vehicle that is our vehicle, right? So this time it's a contract to provide a service. But there's still a significant amount of insight into the process, and I have not personally been involved in commercial crew, but we have folks that have been for a long time now and continue to be. And it's not just the crew office, it's all the other organizations. And my impression and my understanding and the feedback I get from the folks is that the working relationships are in general very good. Everybody's trying to do the right thing. I'm confident we're going to have, a good understanding and a good insight into the vehicle before the first flight.
There was one more. Last question.
Jeff, these two spacecraft as safe haven at station or crew bailout, are they certified to satisfaction?
Oh yes, they'll have that same requirement capability as Soyuz does. So they will be the lifeboat to leave station. Oleg has a short question. They're all short, right?
Yes, all short. So the question is, your prediction, because it's very it's expected that during the first rotation flights we will not Russian and U.S. astronaut cosmonaut in each vehicle. Because it's supposed to be assigned the crew members this September for this flight. It's because we have issue with certification. It's more likely. So for the first flights on commercial, we will be no Russians and vice versa on Soyuz. Do you have like a backup plan, what to do, how to organize the process on station, operational process?
I don't know if I understand the question. Like a backup plan to what?
Because, for example, if we fly, only Russians will fly on Soyuz, only US crew members will fly on commercial.
Well, I'm assuming that will not occur, that we need to find a way to work through the path so that we end up with, on the rotation flights, not the pre-certification flights of commercial crew, but post-certification rotation flights, taking expeditions. We've got to find a way to have the Roscosmos feel comfortable that the vehicle is certified to put a cosmonaut on it. And we need to find a way also to continue to have an American on the Soyuz.
Yeah, that's true. But according to this sequence, the crew had to be assigned last month an MCOP meeting. Because we passed already this deadline and moving forward with no assignments, so it's like no training for that. That's it's very likely we don't have this plan.
Well, the last month we got a little relief on that last month deadline to assign crews for training, based on some delays and the procurement of those additional Soyuz seats. So that delays the requirement a little bit. But I will acknowledge that we're getting very tight to integrate these details, to get the crews assigned on time, to get the training done, to get the spacesuits built, to get integrated into the plan to be ready to fly when we on the B line run out of Soyuz opportunities. So, yeah. More work is to be done.
Thank you.
Yeah. Thank you.
So that means that we go now to yourself, because, well, we started, of course, yesterday with 60 years Sputnik, next month 60 years Laika, and then the whole beautiful history of the Russian spaceflight. But what's next? Moon? Mars? Alec will tell us about it. Alec.
Добрый день, уважаемые коллеги.
Good morning, ladies and gentlemen. I'm going to be speaking in Russian, and the presentation is also in Russian. I was obliged to prepare this. I didn't have a lot of time to prepare this, so I wanted to present the vision, the view of Roscosmos with regard to the future program, including Deepspace Gateway. In fact, that is an international program for the creation of a station near to the moon. This slide shows a development plan for space exploration. There are two main parts. The perspectives for the use of low Earth orbit, and also a flight program to the moon. This is a very large-scale program that concerns all of us, not just Roscosmos. And what we must do, the questions we must solve, are the types of flights that we will be running to both destinations, because certain parts are very costly and will be very difficult to develop. Also, the infrastructure for low orbits is a very important question. And the state also wishes, in fact, the states are less and less eager to commit money to these programs and are taking increasing interest in private investments and programs. So, what will we do after 2024, when we stop operations in the International Station? Well, there are four possibilities. The first scenario would be the extension of the International operations in the International Station, and the creation of a Russian orbital station with foreign participation on the basis of the Russian segment. Yuri Tsitsenko talked of this yesterday. And that is an extreme option if the rest cannot be achieved. Therefore, the possibility of remaining in close orbit with a module. So we can't really talk about a station when we have one or two modules, but it would be very different technical development. When we look at the program for the exploration of the moon, this also includes 2 stages. According to the Roscosmos strategy, our objective would be to explore the surface of the moon. So we participate in Deep Spaceway within the framework of international cooperation. This was declared already at the MAFA Congress in Adelaide. So there are also different types of vessels that would allow us to explore the moon. So this is a very brief presentation of the different types of apparatus that are already being developed. I think that Russia is the only country that is already producing vessels to explore the moon from for Earth launch or from an orbit position. And here is the technical data for each vessel. Speaking of the Russian orbital station, we intend to create this after 2024 on the basis of 3 of the most recent Russian modules that will be placed in orbit at that time. The laboratory module, the scientific module, and the energy module. The fuel module. So there must be at least 2 modules for the station to be able to operate. And the SAS module is also a transformable module that would be used for logistics tasks and others. In order to run this very ambitious program, we must define objectives for our flights so that we can reach the moon and Mars. The Russian Space Agency must draw up a roadmap, and we also intend to redesign the plans for laboratory experiments in order to carry out different tasks for moon exploration and also for missions to Mars. So we have better reallocated tasks and payload, and with a commercial component also. So in fact, this would involve the commercialization of low orbit flights, and the commercialization should already start now and involve the International Space Station in order to develop a portfolio of clients. This is a table that shows all of the different technologies that we must harness in order to travel to the moon and to Mars. If we consider flights to the moon and also in the NRHO orbit, within the case of the ICST, we've already done a feasibility project in order to distribute the roles and to determine the configuration of the vessel that's called the Deepspace Gateway. This will be for flights in orbit, and the contributions presented on this slide are have already been defined, but we need to develop these further. This would be a small station for which we need to develop technologies to explore more distant outer space. When we carry out the studies, we wanted to define the orbit for this station. There are Kepler orbits, and we are used to exploring for close outer space, and we chose an orbit from the Gallo family. There are, of course, advantages and disadvantages to this. But international partners decided that this international platform would be created for orbit. This is what we're presenting. It's not a flat orbit. This same orbit would be used for the moon. It is a wide orbit, and of course this creates stronger demands with regard to the this will require more stringent demands for the vessels that will be launched. So we need to take into account which requires the reorientation and the efforts required are considerable. This is the basis of our calculation. So the Russian strategy with regard to the surface of the moon would be developed according to a roadmap also, which can be split into 3 stages. The first stage is the forepost. It would be the first and the second stage. We need to define the objectives for each stage, and the repetition, in fact, of the Apollo program. It would be a very short stay for the 2 astronauts on the surface of the moon in order to establish a forepost with a team of 4 people for a duration of about 30 days, and they would use exploration apparatus to explore the moon in greater depth. We also plan for the creation of a stationary infrastructure on the surface of the moon that can accommodate expeditions, a station where they could stay for periods of up to 60 days with all of the necessary equipment. And other stages would require more other stationary stations to explore not just the surface of the moon, but also to undertake industrial tasks. For example, experiments on how to use moon resources for industrial production. We have also presented a scenario that has been calculated, and the creation of a heavy launcher will be required in order to complete these tasks as from 2028. Thank you for your attention. I will be happy to answer any questions.
Excellent presentation. Thank you. I'm curious about that eccentric orbit around the moon and the motivation and opportunities that orbit provides.
Well, this orbit was chosen in order to accomplish auxiliary tasks. So we wanted to choose an orbit that could be attained from the moon, with a 1 kilometer, with a defined speed. And this orbit is also lit by the sun, and the energy expenditures would be minimal. The engine would be a reaction engine and an electric engine, and that's very important. So the thermal technical origin and the conditions of the thermal regime would be close to that used in more distant outer space, and we would therefore be able to test this, the system for more distant missions. So the shadow is also minimum in this orbit, and that's why radio visibility is better. Also, the conditions would be close to more distant flights. So the idea is really to enter into a non-Kepler orbit. And if we can learn to evolve within this type of orbit, this would prepare us to fly further out and to use this type of orbit in the future. Thank you.
Well, space stations, we use them for research. Outposts can be hotels, way stations, and even human habitats. But also there's another reasons where we can use space stations for industrial stuff. Because we already do industrial experiments, and the future will be very interesting in that field. And Mike will tell us about this commercial space station. Mike, all yours.
Thank you, André. Good morning. Dobro utro. Buenos dias. So I'm going to ask you to really try to change your mentality a little bit and think about commercial as an alternative successor, let's say, to government space stations. Oleg mentioned one option that Russians are considering having a follow-on government station. But if that does not appear, or since it seems to be uncertain, I'm working with a company called Axiom Space, which is trying to do something similar, but purely commercial basis. So I gave a bit of this presentation last year in Vienna. I just wanted to kind of review some of the high points and also give you an update on where we are. So while this slide is up here, and I'll sort of let you read it while I talk, you know, it has historically been the role of governments to open new frontiers. Those can be geographic frontiers or economic frontiers. So that means when the risk is very high and there is either no profit incentive or unknown profit incentive, it doesn't make sense for companies to go to try to do something there. They won't do it because they don't have any proposed return on investment. So this happened when the Spanish Catholic king sent Columbus across, stumbled upon America. It happened in the United States when we did our westward expansion. And it is appropriate, however, that once the beachhead is established and there's security or there is a market that is proven or at least possible, for the government to step out of the way and to allow commerce to come in and take its place. And I would propose that that's what's happening now in low Earth orbit. Jeff talked to you about the transportation aspect of that. So NASA has invested a lot of development money in first cargo and then crew transportation to get to LEO. But as of right now, we have no commercial destination. And if you think that the ISS is going to be deorbited in 2024 or 28, we need a place to go. I don't think anybody in this room would like to consider the likelihood or the possibility that we're going to abandon LEO. I think Jeff pointed out that if we start flying, at least in the U.S. side, on SLS every year or two, it's going to be really difficult to maintain political support without a sort of constant human presence, not to mention all the more important reasons to go to low Earth orbit. So this sort of describes that. There are demands that I'm sure NASA and the other partners will have to do continued, first of all, human research in low Earth orbit to continue to understand the effects on the human body, and also to test technologies in LEO. Right now we have an environmental control and life support system on ISS, which is very rickety, requires a lot of maintenance, which requires a lot of upmass, which obviously is very difficult if we're going to do deep space exploration, which I think is everybody's goal. Similarly, there are a lot of countries, some that don't have human spaceflight programs and others that do, but don't get to fly enough for the reasons that Jeff mentioned in the multilateral crew operations panel. Has a very elaborate way of determining how many flight opportunities are allocated to the different partners. And if you're a European country, that European allocation is now divided among a larger number of countries. And so we think that there's a lot of unsatisfied demand for government astronauts as well as private citizens, which you've seen not so much lately, but in the middle of the 2000s there were a lot. So what are the lines of revenue that we could think about in a commercial space station? Well, they are here before you. Education and outreach will continue to be important. Anytime we have people in space, it's a great source of inspiration for the future generations. Research and tech development in microgravity, i.e. what the ISS is doing right now. Advertising and branding, clearly not what the ISS is doing right now, but we think that there is a market for that. There's a lot of potential for making movies, making commercials, that sort of thing. I think in-space manufacturing is going to be slow to start because we'll have to prove the things that are being done in the national labs today through cases, which some things are being successful, but once they become proven as an idea, CASIS gets out of that because it's no longer a laboratory, it's now become a production facility. But there's a lot of excitement around something called Z-band fiber optic cable manufacture that is, even with today's launch prices to get the raw materials up to space, would be very lucrative to go up to space, fabricate them, bring them down, and still make money. And then perhaps what's most interesting to us is human spaceflight programs, and as I mentioned, it's not just commercial, it's not just government astronauts, it's also individual tourists. A study was done, and these are the numbers that came out. Those are the different lines of revenue that I just talked about over the years. The bottom line, in the 15 years or so ending in 2030, we're looking at a market somewhere between $35 and $40 billion. I don't really think I need to spend much time talking about this. This is why countries want to go to space. One of the reasons why they want to go to space, because it is an inspiration for them, that for their youth, that makes people want to study science, technology, engineering, and mathematics. That means those people end up becoming part of a technologically advanced workforce, which makes them have a higher status in the world when they're a spacefaring nation. So how does Axiom want to do this? Well, we want to build 2 modules that will launch to and dock to the ISS in 2021, and then in 2024, or whenever the ISS is deorbited, those 2 modules will detach. During that time, they will have been added to by a couple of other modules and become a free-flying independent commercial space station. Sort of what they look like. These 2 modules are about the size. The first one looks a lot like a node. It is basically node 2 with an extra bay in it, and the one on the front is basically an MPLM with an extra 2 bays in it. They are obviously they have conformal arrays. They have their own propulsion modules that will allow them to do what the cargo vehicles are doing today. So they'll do a rendezvous, proxops, station keep will be grappled by the robotic arm and then attached the CBMs on either side. And then on the front of this, what you see is a NASA standard docking system for a commercial crew vehicle to come and take the people. So each of these, the total 2 modules will have a capability to have 8 astronauts on board at the same time. They're 2 separate ecosystems that can support 4 people each. Our plan right now is not to ever fly 8 people, at least initially, but we have a couple of different modalities of short duration flights and long duration flights, generally with 4 people, which is being driven basically by the size of the commercial crew offerings out there. It's conceivable we could have both of them visiting at once. And then this is what the station looks like. You can see that some of the pieces are from the previous picture. That beautiful feather-looking thing is actually a solar array that is folded up nicely and launches under a normal fairing and gets deployed once we separate. There's a second habitation module, there's a manufacturing module, and then we'll probably steal the PMM, the pressurized, what is that, multi-purpose, the MPLM that's up there now that is permanent. And the cupola, I was talking about the airlock, but I think the airlock will look like the airlock that's on board now, but it'll be new. Here's a timeline. I think the first thing to talk about is you see the first cruise to ISS in 2019, but I said that the modules don't fly till 2021. So what NASA would like us to do, and we wholeheartedly agree, is have a little practice before we start bringing people to our module. So a flight might look like 1 professional astronaut with 3 tourists, or maybe 2 professionals and 2 tourists for a short duration, say 7 to 10 day mission. Or it could be a reduced number, probably 2 professional astronauts for up to 60 days. And the ECLS system aboard the ISS has a capacity to absorb that increased load. Of course, there's a lot of back and forth between us and NASA about how we pay for those resources. And if I didn't mention it, the guy running Axiom is Mike Sefferdini, who was the program manager for the ISS at NASA for 10 years, so he's pretty educated on how to do that. And then in 2021, the 2 modules arrived. That's Node 1 and the HAB. Then we bring up the research and manufacturing model in 22, the power and thermal module in 23, the airlock in 24, and we're ready to undock as soon as 2024. I think there's some folks thinking that it's going to go to 2028, and we'll be happy to stay on board. Now, the interesting part is how do we transition the research that's being done on ISS, which is heavily subsidized now through CASIS, to a purely commercial model, and that's something that we're working with NASA and with the other partners. But clearly, we can't have a government-subsidized operation at the same time you have a commercial operation, or if you're a customer, you know, it's not an IQ test, right? You're going to go with a cheaper option. So there's some challenges, no doubt. We want to try to make this cost a lot less to operate than the ISS. The ISS is completely unviable as a commercial platform right now. So we're taking some of the plays out of SpaceX's playbook in terms of using standards that are, we think, adequate, yet not quite up to what NASA would demand. Obviously, it's got to work, it's got to be safe, or it's not viable. We want to make it plug and play so that when a researcher goes up there, he doesn't have to think about how to interface with a 1553 bus. He can use a normal Ethernet cable to plug in, and there'll be normal outlets with 120 volts AC current, not DC current or anything unusual like that. Things that we can buy off the shelf, we're going to try to maximize. We're going to try to keep all the ORUs inside so we don't have to do expensive and difficult EVAs to replace things when they break. We want to have competition among other countries to help us with our subsystems. There's some interest on the part of some European companies to produce some ECLS hardware, and we're all about that. From an ops standpoint, we want to make it simple. We spend a lot of time on ISS today, swabbing the surfaces and measuring the air cleanliness and things like that. These are things that can be automated today. Back in the day when it was designed, that was the way it is, but it isn't anymore. And we've learned a lot in terms of crew activities and how to plan for them, give them some more autonomy. The vehicle will be very automated in terms of fault detection, isolation, and recovery, etc. So this is a purely commercial venture. We're not asking for any development money from NASA. The only money that would be required is as we attach ourselves to the front of ISS. We are going to do that for some resources, namely power and cooling. So there'll be some modifications that have to be done at that interface that I think would be, very inexpensive, relatively speaking, to NASA. This allows us to, a lot like SpaceX and Boeing have done it with commercial crew, be able to design the system using the standards and the materials that we want, so long as we meet their requirements. We still have to meet the same, whatever that number is, 55, 80, or whatever the requirements are to get when something gets within a certain bubble of the ISS. But we think we can do it more efficiently than a typical NASA contract would do it. And then the institutions, meaning the government, gets to have a service that they can buy. So if you're spending $3.5 billion per year on the space station like NASA is doing today, perhaps it's interesting to you to spend a couple $100 million to be able to still have the same kind of access for your astronauts to get to and spend time on an orbiting space station. We also think it's important when we start thinking about going beyond LEO to explore cislunar space or whatever it may be, that we increase the number of spacefaring nations that are doing it. Right now, it's sort of the same gang of 5, the ISS partnership. You might think about including the Chinese, but why not include the resources of the entire world? And by making some of our professional astronauts be from countries that don't have human spaceflight programs today, we can affect that. And finally, we want to be there to be a LEO platform should NASA, ESA, JAXA, CSA, or Roscosmos want to have a place for their astronauts to go, but we don't count them as an anchor tenant. We think that there's going to be enough demand without them. So when I talked last year, we were talking about one module that would go on the front. What's changed is that there's a fairing that was being developed. It was going to launch on a Falcon Heavy. The fairing development, which was for the Air Force, is not proceeding at a pace that we're comfortable with, so we split it into 2 modules. Turns out there are a lot of advantages. They launch on Falcon 9s with an existing fairing, so it's pretty simple. We have, I think, I hate to say perfected, but we've settled on a design of a completely green propellant that is basically free, if you will, using the Sabatier process and the process that we already use today to generate oxygen on board. We can actually produce O2 and methane and use that for our capability to do reboost. In fact, we want to offer that to NASA as a capability even during ISS. I think I talked before about trying to make the interface to the users inside be a lot simpler, and so we're going to great lengths to look at existing laboratory facilities on Earth and try to mimic their characteristics to make it such that researchers can go through a little less agony than they do today to try to get a payload on board. By the way, each crew quarter is going to have a gigantic window, half-a-meter window, which I think will be a pretty good selling point. So a couple things that are interesting. We've got some partnerships going. SGT, Stinger Gafarian Technologies, is, first of all, our parent company, and it's also the second largest contractor at NASA and the contractor that does all astronaut training for all of the ISS astronauts as well as all the flight control functions for ISS. So we have a lot of expertise in-house, and what we plan to do is use the people that are training the astronauts, and they would train our professional astronauts. And so when I say professional astronauts, I know it makes people in this room cringe, but We're talking about taking somebody who is a member from either a country that doesn't have a human spaceflight program today or one that does, sending them through a training which is very similar to ASCAN training, so that at the end of that, they are at least user qualified on all of the ISS systems. They've flown in the T-38, they've been in the NBL, they've been through robotics training, and we want NASA and the rest of the partnership to look at them as being fully qualified ISS astronauts. That's a unique capability that we have because of this relationship with SGT. And what we would do then is using those personnel, and then we would lease the training facilities. Obviously, we're not going to build an NBL, so we would lease the training facilities from NASA. And we're in conversations with them right now to have a reimbursable Space Act agreement to do that. Intuitive Machines is another sister company of ours, so another spin-off company from SGT. Some of you may know, but there are a lot of NASA engineers that have gone to go work for this small startup. They've got a pretty nice sized workforce now, and they've done most of the design engineering for us. These are all space experienced engineers. Thales Alenia Space is going to build the modules. They built 40% of the pressurized volume on ISS already, so the tooling is there, the know-how is there. The modules, as you saw from the outside, look a lot like ISS modules except for the conformal arrays, so there'll be a lot of capability there. And then some of the players that you see there, Honeywell, UTAS, which used to be Hamilton, Paragon, Orbitech, these are system developers, a lot of whom have supplied equipment to NASA, but our idea is that we want them to build stuff for us to commercial standards, not government standards, provided they are functional. And then Boeing would be responsible for that integration that I described to get the first module integrated to the front of ISS at Node 2. Does anybody have any questions? Richard.
Mike, first, very exciting. Obviously, as a commercially focused guy, I'm very fascinated and interested. Two questions. One is, where is your primary financing coming from so far, and what do you estimate, or if it's public information, as to how much you think it'll take before you actually have, how much financing is required prior to flying a passenger up?
So it's, as I said, it's purely commercially funded. So the funding comes from investment, first and foremost. Well, first, maybe not foremost. The other part is just from deposits on spaceflight. So if you want to fly in space, you have to give us a deposit as soon as you sign, and then there are milestone payments so that by the time you fly, you've paid us a lot of money already. I don't really want to get into the total raise, but it's the number doesn't start with a B, if that helps. Now that's the total cost is more than that, but again, we're going to subsidize the cost by the revenue from the deposits. Bonnie's got one. Madame la Présidente.
Just a couple questions. Will it have an EVA capability, and if not, why not? And what kind of communication system and ground control system will you implement for it?
It will have an EVA capability once we undock. The airlock comes up sort of just before we undock. We have to have it for obvious reasons, but we do want to make it as internal IV friendly for repairing and replacing boxes as possible. So I think Mike Sefferdine would tell you we kind of made a big mistake with this great big truss structure. All the boxes are outside, and the number of EVAs now, I think I was talking to somebody in the office who is responsible for that now, seems to be going up because, you know, naturally things are starting to reach their mean time between failure. So it's an expensive and disruptive activity we want to avoid as much as possible, but it is definitely going to be a capability. The comm system is TBD, but it'll be commercially, you know, there are lots of options now with commercial. It'll be satellite, it'll be very high bandwidth, because a lot of these things that we want to sell, like making commercials, need, you know, high definition TV, etc. We may even, we may even buy, you know, TDRS space, but it'll probably be too expensive.
Ground control?
Ground control will be done from probably Houston, and it'll be, if you've seen, the SpaceX model that they use in Hawthorne, something similar, very, distributed, very automated, but it will have a team. We're going to start that right away, even when we have people on board, even before any of our hardware gets there.
LA.
Yeah, Charlie.
Couple of things related to the seriousness of the relationship with NASA. You mentioned conversation ongoing about an SAA, Space Act Agreement. Is there already a Space Act Agreement or a signed relationship in any fashion? And related to that, your timeline, 2017, 2018, you had 2 blivets on there, 2 points. A port commitment at ISS and training of astronaut and crews. What progress in those regards?
You're a great straight man. So yes, we do have a signed Space Act agreement with NASA right now. That's enabled them and us to do a pretty detailed feasibility study on all this. The Space Act agreement is phased, so we have completed phase 1, or maybe it's phase 0, I don't know, and we are now working on the next phase as we go. The port commitment is a really big deal, and I'm sort of glad you brought that up. So there are other companies that would like to do the same thing. At least one company, Bigelow Aerospace, has announced intentions to do something similar. So NASA has to figure out how to decide which company to go with. This process started quite a while ago. They realized that this is kind of a big deal. It's not going to be a procurement, it's not going to be an RFP, and it's not going to be an FAR, a Federal Acquisitions Regulation type of procurement, but it is going to be a competitive one. So they asked industry through an RFI, a request for information, last summer, if we wanted to give away unique resources on ISS, like, say, a port, how should we do that, what criteria should we use, etc. Industry responded, I think, in October, and everybody thought this competition announcement would be imminent. It's now October. So we're all waiting, but we hear it may be tied to getting a new administrator on board, but I think soon we'll have that competition announced, and we're thinking a couple, 2-3 months for the competition, probably some protest time, and then we'll be off and running. And that's important for investment, as you can imagine. Is that Mario in the back? Oh, I'm sorry. Yes, Franco.
Very good presentation. Have you thought about looking from your module? You said there will be a cupola or something like that, or the MPLM will be modified. What is the approach to
the habitation module, which has 8 crew quarters? If you think about the way ISS is structured today, with the bays running sort of circumferentially, our approach is different. The bays are going to be longitudinal, and so if you divide the circle into 8 different wedges, there will be wedges, 2 sets of 4 wedges on the bottom. Each one will have an Earth observation window. Those are the crew quarters, and we're having them, we're designing them with I'll say a well-known designer today that will make those nice. And then when we depart the station, we would like to take the cupola with us, the existing cupola. I mean, I'm assuming that when we depart stations, because it's going to be deorbited, obviously it has a lot of certification on its life left, so we'd rather not throw it away. And it's a very popular place, obviously.
This adaptation will be done by Thales in space?
No, the existing cupola that's on ISS, yeah. Well, the windows will be integrated into the HAB module, which is effectively an MPLM shell.
Yeah, Mike, great presentation. I have, I guess, a couple of comments, a question, and then an offer at the tail end here. First of all, PMM, just you went, it's permanent. Multi-purpose module, that's what they transitioned from MPLM. The other thing is, I think for the community here, operationally, the ISS program is currently in the flight rules that are being generated for things like the mean time between failures, or more appropriately, usable life out to the end of life for station. The number that's getting put into the flight rules seems to be 2028. That number's popping up, so I know we've been talking 2024, but at least from an operational and the guys that are, the ladies that are doing the planning for keeping the thing running, that's what they're thinking, and I think they're covering their bets at that point. And then the question then is, I guess for you to take back to Mike, is while he was with ISS, why didn't these great ideas like, you know, the outlets and the power, why didn't we do that in the first place? Or get it implemented and transitioned along the way? Now that he's got the freedom to do it, I guess he can do it. But that seemed to be, at least initially when ISS first came along, it seemed arcane to design it the way we did, and all these things that you talked about seem to be great ideas. So I guess there's a profit in it now. And then the offer at the end is I know you mentioned you got a designer, but if you want the windows done right, give me a call.
Okay, Mario. Just on the outlets and stuff, I mean, they've done the best they can. So they have big power strips now that have 110 plugs in them, but they're plugged into 120 volt DC. Yeah. It's just hard to put a Band-Aid on a pig or whatever, however that phrase goes. Jean-François. Jean-Claude, sorry.
Yeah. Knowing that when ISS stopped, there will be other stations in low Earth orbit, Russian, Chinese, maybe both. Why not continuing the partnership with other space stations? Why, rather than going autonomous, fully autonomous Axiom?
I think mixing a commercial entity with a government one is very difficult. You know, and again, back to my original analogy about opening new frontiers, I really think that we've been going to low Earth orbit for 60 years now. If there's ever going to be a time that we can see if there's a viable commercial market, it's now. And I don't think there's much to be gained from joining with another nation state, and potentially a lot to lose. You can't have a competitive model alongside a subsidized model. That just doesn't work. So, you know, I don't know the pedigree of the plans for the Russians to have a follow-on station. If there is one, it's going to be interesting, right? Because I think they will be using it for commercial purposes too. It becomes a price war, which is good. Competition is good.
Thank you very much. And now it's time to get out of your seat and get some coffee. You have a break, 15 minutes, and we call you back in. Okay, we do. Good. You're watching your ATV coming. Great moment, beautiful spaceship. But there were only a few. But the technology is not lost. We will see it back in the next presentation. And Olivier, you will talk about it, because we go on with this technology, even maybe to the moon. You never know, and we hear all about it from the next speaker. The floor is yours.
Thank you very much, André. First of all, very welcome to Airbus. It's a great pleasure to have you here. Now, of course, it's putting a small difficulty on me, because last year I had the pleasure to be with you in Vienna. Now, I don't know whether you're here inviting me because of this, or because my talk last year was so fascinating that you wanted to follow up with me on this one. Nonetheless, I assume it's the latter, and I'm trying to guide you through a couple of topics that we're after. And hopefully you will see the connection to the talks that you heard before. So let me just start with saying today, for me, really, it's fascinating times. We've been 2-3 weeks ago in Australia. Some of you have been there as well. And if I just point on 2-3 messages that we learned there, I heard Bill Gerstenmaier in a very exciting panel discussion say this the first time that latest in 2019 we're going to have the decision to prolong the space station operation until 2028. We also heard that Roscosmos and NASA has signed an agreement to collaborate on the Deepspace Gateway, which also means that we will very, very probably see Russian astronauts on Orion, as we hope that we will see European astronauts on Orion. So these are things that are, in my view, extremely exciting because they are making reality what was dreamed before, right? Because it's reality that we are in low Earth orbit and that we will stay there. And I believe now also trying to give you the industrial and commercial perspective always, I believe if we do that, we extend until 10 years from now, and that's a very decent time period to recapitalize on investment. So if you have that planability, it is much easier thing to make a decision on invest than every year prolonging a little bit longer. So that's really great news. And from that perspective, I was just reflecting, my God, I mean, 60 years that we are in low Earth orbit, 60 years that we can credibly say that we're doing space, not only human space, but space. And if you go back, seeing the site here where we're building aircraft, if you go back 60 years ago on aircraft building, that was around about the time where we started to build the first all-metal aircraft, which was about the time to talk about industrialization of aircraft building. And if you then go further 60 years, you're back into Brothers Wright and the first beginnings of flying at all. So that's around about, this time span, 60 to 120 years, with a milestone in between where you were talking about industrialization. So now, if we talk 60 years space and being almost permanently in low Earth orbit, what does it mean for the next 60 years? And have these presentations that you've been seeing so far, is this like now the stepping stone that where we are starting to look back in 60 years from now and say, look at something similar like this here, where we are building chain production, A380, A320, whatever, where we have built up an ecosystem about aircraft and flying that is just enormous. And will that be the same for space? And my prediction is it will. And there's a very simple reason for that, and that's completely irrelevant with regard to space or technology. Mankind, in my view, did never go somewhere to then abandon the place and never go there again. That means we have started with being permanently present in low Earth orbit, and I utterly believe that we will not leave it. And we've started to go to the moon, and we will go back to the moon. You will very soon see that in my slides as well. And this means we are expanding. And that's a normal trend, that we've always done that, on Earth, in the sea, and we'll do that in space as well. So my prediction is it will come. It's just a question when it will come and how we get our things together, because what I was elaborating on with these 60, 120, and then in 60 years from now, this is really linear. It's easy to predict that. It's slow, and many of us will not even see that, such that we cannot be challenged on it. But now if you go to mainly also to the US, people talk about digitalization. They talk about exponential development. So what do we need to do to make space and growth in space an exponential development such that we can all see that quicker? And that, I think, is a guiding question. And here, I think, we need to understand what do we need to do, not only in terms of budgeting, taking decisions, but also technology-wise, that we see a process that will make this quicker. And if you take a look at my first slide, this is Orion. Talking about the exploration mission 1, this is bringing humanity back into the lunar environment. And I put you a picture which is not a very recent picture, but at least one thing which is cleared by export control. So you see that this is currently the status of the European Service Module in Bremen. And many of you have been visiting us already in Bremen to take a look at that physically. So you're invited to this as well. Please come back and take a look at the current status. If you take a look at that, and this is something that also for me was a bit of a surprise. If you really go into the detail in the work that we do with NASA, this is flying to the moon, yes, but it's a lot of detailed engineering, let's say, linear work on mechanical stuff. It's a lot of talking about weldings and how can we prove that the welding of titanium for propulsion substances is good. It's a lot of leakage on metal bellows and valves. This is what we have to resolve to fly to the moon. And there's good reason for that, because there's safety involved, right? So this is the bit which I wouldn't say is slowing us down, but this is the step, the hurdle that we need to take. And although we're really experiencing that, and not just Airbus, but the whole community, it's surprising to see how much new issues we're still finding. So nonetheless, this is the rock bottom work that as a spacecraft designer you need to do in order to build it, to deliver it, and then to fly safely with crew. And we've depicted here the profile of the first mission. It's back to the moon, and now you could say it's not very spectacular because it's sort of a you fly there and you fly back immediately. You're not staying there. And it is true for the first mission, which will be an uncrewed mission, because really this mission is also for checking out the systems, to making sure that all the systems work appropriately. And you know that we are already under contract for the second flight, and you will not be surprised as well that the second flight profile, if this is the mission profile for the exploration mission 2, is not significantly more ambitious. That's at least how it looks like at the first sight. But let me poke on a couple of topics which are important also for the letter of my talk. The first thing that you see here, and I'm not going to go into the detailed steps there, after one revolution around the Earth, we need to check out direction moon. That is not only because we want to fly there as quick as possible, that's not the point. The point is we're designing an exploration vehicle, so mass is an issue. And mass becomes an issue if you want to protect yourself against debris that is in low Earth orbit. So that is also an issue that we found when we had different design points. Can we fly with Orion to the space station? Can we fly at the same time with Orion to the moon? Yes, you can, but there is a couple of different things, right? So in terms of debris protection, you definitely need to have a little bit of pounds more on your hips. And that is not necessarily helpful if you want to fly as far as possible where you haven't been before. So here really we need to be aware that still we're doing things which are at the edge of what is physically capable, right? And we haven't done it before. So here that's one of the challenges that we are currently working, and space debris is an increasing topic, and we need to fight this. If we want to go further, we need to make sure that this is taken care of appropriately as well. Second topic worth mentioning here, you see the exploration upper stage there, and you see that there is a co-manifested payload. So the SLS launcher is dimensioned to carry more than Orion. And guess what it is? It's the first element of the Deepspace Gateway. So if you've learned about the Deepspace Gateway here, also that is not just PowerPoint and some discussions, it's reality. I mean, we're under contract for EM2, and if there is a co-manifested payload flying with us, they better get on track right now in order to be ready for launch. So this is reality, it's happening, and if we take a look at that, and of course there are different pictures of that, at the end I believe it's going to be one collaborative topic. The Deepspace Gateway will bring us, as you've seen from the talk from Roscosmos, in the lunar environment, in the lunar orbit, and it will allow us to expand our capabilities from low Earth orbit there. We can do that because we have exercised it in low Earth orbit over a decade, more than a decade right now, professionally, all the logistics about it, even for the supplies, late cargo, the way how we're building it, the criteria against which we're checking the safety. So this clearly proves we can do it, we're ready for the next step. And after we've done that, we will do the next step. And just to come back on Orion, Orion is designed for Mars. Lockheed keeps saying it's a 1,000 days vehicle, so it can fly to Mars. It's a question whether you wanted to fly an Orion to Mars because it's rather small for a long trip. So you need extra space, and the Deep Space Gateway will feature additional space to stay longer, right? So you're seeing that even though at the first mission with Orion we are flying, let's say, short missions, comparatively short missions, we will extend those missions as we continue. And if we fly 1 or 2 missions per year, we will have the chance to do that and to stay longer. All right, so Orion is a shuttle. It shuttles you somewhere, and then you need to define what you want to do there. And if this is the Deep Space Gateway, let's go into the next step. You've also seen in many talks and discussions that not only we're interested in, let's say, the lunar environment as a proving ground to then go to Mars, there's also a great interest in going back to the moon. And here this is something that we are currently very interested in from two different perspectives. On the one side, we're collaborating with the European Space Agency and Roscosmos in a project that we call Pilot, but effectively it's a vision-based navigation system that we will fly with a Russian platform and a Russian mission jointly to go there. Collaboration. Yeah, you can collaborate with all partners who are interested, independent of their final goals. So this is a very important thing. And at the same time as we're doing that in the classical agency approach, we are very interested in looking at companies which are trying to sell services to the moon in a more commercial manner. Naming Astrobotics, for instance, from the US, or naming the PT scientists in Germany. So here you get a deal, a kilo to the moon for $1 million. Whether that equation will work or not, we will see. But we are following these companies, also supporting them technically here and there with our system expertise to make it happen. Because at the end, we will need transportation means in order to do what we want to do. And let me just poke that also when we discuss on all these follow-up stations and the costs associated to it. Today, our understanding is that at least 70, if not 80% of the overall cost of operating space infrastructure is on space transportation. So we can optimize and fine-tune our processes how to operate that orbital infrastructure up there. But if the transportation cost is not going down, then we will never be significantly cheaper. And how you bring down transportation costs, again, you see that in the aircraft business. It's a question of scale. If you're allowed to build more of those, then automatically the price will go down. So as we continue doing things, we will do more of that, and this will cut the price. You don't have to be a rocket scientist to find this one invention which makes it cheaper. It's really a question of scale as well. So if we're going to the moon, of course, we also want to go back, because one of our scenarios is very clearly that if you have the Deepspace Gateway, not only from there you can very easily control and monitor robotic activities on the surface, or support man-tended missions on the surface, but also you could shuttle back and forth with a lander, with an ascent vehicle, refuelable. We heard in situ research utilization. So how can we use moon, water, ice, material in order to generate propellant? And we heard from Axiom that they're after the same thing. You're using processes, you can call it green or not, but it's fossil. It's something which is available over there, and everything that is available over there, you don't have to transport. So one of the elements that will help us to bridge the gap between what we do with human and what we do in exploration, where even if you go to Mars, then the distances for communication to travel will become longer and longer. We believe we need to invest into robotic infrastructure. And one thing that we are currently doing is we're investing in intelligence in space, autonomous intelligence in space, and we currently call it the Space Tag. It's a vehicle which is having artificial intelligence to judge itself what it shall do. In the first business case that we've calculated, it can refuel geosynchronous spacecraft, so telecommunication spacecraft. This is a purely industrial business case, but it could as well remove debris. It could as well help bringing logistic stuff, other modules to the Deepspace Gateway. It will help doing teleoperations when you know that you have a slack of 20 minutes if your communication signals travel to Mars. So we believe that with the digitalization on Earth, we've made a stepping stone that allows us now to more or less transfer the NVIDIA graphic controller that all your kids are using when they do the gambling into space. And if you have the same performance in space that you have on Earth, then you can do much more things. And maybe then we see an exponential development, because then you will have an enabler for doing all this manufacturing in space, doing space for space manufacturing. Zibidan was mentioned, which is a very interesting case. So what happens? The fact that we are currently seeing is that as agencies are going on exploration, there's room left for commercial activities. So we will create an orbital economy. And an orbital economy will grow if you stimulate it. And one stimulation that we are currently benefiting from is a platform that we call Bartolomeo. So it's a little bit like Axiom, but only outside. It's like a balcony that we put to Columbus. And we've taken a somewhat bold investment decision on our side. So Airbus is investing into that with the support of ESA and NASA. And we want to provide the first fully commercially accessible place on the space station, giving access to agencies that are currently not having access. We've been in talk with the announced Australian Space Agency, with Singapore, with the UAE. We will talk to the United Nations, but also to commercial companies. So here you can really now buy access to space by kilo again. And this can be a school experiment, as they've just announced in Australia that they're going to fly a 1 kilo school experiment as a competition, but it could as well be the next gen transponder technology that a company wants to test over there. So this is socializing overall cost. As lunar services will socialize overall cost, you can pay by the kilo. You don't have to buy a launch for 30, 40 million. This is a way to bring down transportation costs. A way to bring down transportation costs is as well in-space manufacturing. You're reshaping your value chain. We're designing satellite and orbital infrastructure to survive the launch. If you don't need to do that because you're building in space, transportation costs will go down. So it's a different way of approaching it, and with Bartolomeo now we're taking the first bold steps, and of course, now coming back to what I said about Australia, my statement on the panel was, guys, if you don't prolong your space station until 2028, my business case for Bartolomeo, based on my investments, is calculated until 2028. So I need that decision. But I'm trying to mitigate my risk by also talking to Axiom and saying, all right, if you really do what you do, and if really the space station could be abandoned by 2024, then I will simply dismount my Bartolomeo platform from Columbus and I will put it on Axiom. Right? So we will reuse and we will collaborate, and whether we do that with Axiom or whether we do that with the Russian space station, and with all due respect, whether we do that also with the Chinese space station, we will see. And we believe that if we collaborate, if we benefit from synergies, not only by reusing hardware, but also not doing the mistake again that we are always starting development from scratch. So using synergies that we can use technologies developed for Orion, also for the Deepspace Gateway, then this will be affordable. And if more partners join, even with commercial money, then we can achieve more than we think. And then we may see it earlier than in just 60 years from now. So as Orbital, and allow me that last word, if Orbital economy will develop by itself, one thing is very important for us. Let me call it sustainability. We believe if an orbital economy develops, you must talk about an orbital society. And I'm glad to see also that we will now hear about the Lunar Village, because if you talk about a village, if you talk about a society, that's exactly the point. We need to talk about rules and regulations. Of course, industry wants to get rid of the regulation by agencies that is sort of enabling, but also starting to, cut us short from access to space. But we believe we need to replace that regulation by a different regulation. We need to talk about what is our liabilities if I bring stuff up there. Do I have to bring it down? Will you have to dismount it, and is it part of your business case? We will need to ask our questions on Bartolomeo, as we need to ask ourselves the question on OneWeb mega satellite constellations, and this has to be regulated. And it has to be regulated ideally global-wide by United Nations or whatever, instead of having different national laws. So this is only a peak part of that, talking about liabilities and safety, but it's also a question of how do we deal with one another. And here, to be honest, I'm glad to see that there are so many different nationalities in this room, and you're the best testimonial for doing this collaboratively, and this will be the key to that. So let's talk about society, let's talk about behavior, let's talk about rules and regulations that we all respect to create something sustainable, to not make the same mistake again that we've seen 150 years ago when we industrialized Earth, and now we're still fighting the same problems. So this is what we're standing for. We think we do it stepwise, but if we do it jointly, we can do it quicker. So thank you very much for listening. It's a wide range from Orion to doing all sorts of stuff, and now Lunar Village. That's going to be fun listening to that as well. Thank you very much. And if there are any questions, more than happy to answer them now or in Bremen or whenever you come and visit us.
Thank you all. Very interesting. You mentioned early in the presentation that Orion might visit the ISS. Could you give the context for that?
In the original discussions that we were having between ESA, NASA, and industry on both sides, you know that Orion was designed as a multi-purpose crew vehicle. So it was not like this is the timeline, this is the mission. In fact, that mission scenario is not even frozen in our perspective, to our knowledge, and it could change very well. So the task was to design a vehicle that can do multiple things. So you rather had design envelopes and reference missions, and one of that reference missions was also flying to the ISS. Because clearly from that perspective, there's nothing that withholds us from doing that, although the vehicle currently is a little bit of an overshoot, carrying 8 tons of propulsion, so you would have probably removed 2 of the 4 tanks. But the main topic really is that you will, for certain aspects, not find that you can meet the design point, the optimum design point for various reference missions. And that was where I talked about the debris protection. If you design for LEO, you will find the same topic if you design for radiation for lunar or Mars environment. So there are certain topics where you're saying it simply doesn't make sense. I mean, you could do it, but it doesn't make sense. So that would require a design modification, where currently we're no longer taking that as a reference mission, but it may come back in 5, 10 years from now, whenever, I don't know. That would be speculation, but it was part of our reference missions.
Thank you for your presentation. You explained that you plan to have a space station on the moon orbit, and then you explained you have a tug. Is it a tug from a lower Earth orbit to the moon orbit? If you do it, you have a tug going between the 2 orbits, and in this case, what will be the inclination? I mean, you take a lower inclination, not the one of ISS, but something like a 15, 17 degrees, and you explained at the beginning also that it could be axiom. But axiom, like Mike explained, is on 51.6, because the first module of axiom will be on the ISS, and you cannot go from 51 to 15. So how do you organize that at the end?
Yeah, that's the tricky thing about the space talk, because we use it as a buzzword, let's call it like that. Indeed, the idea is, globally speaking, inter-orbit transfer. So inter-orbit transfer, of course, can be a wide range. It can involve, you go from LEO to lunar orbit. In the more commercial cases, you go from LEO to GEO orbit. The first case that we are currently designing for is we are designing to fly to GEO. And it will be an all-electrical spacecraft. It will fly to GEO, and there it will service existing telecommunication satellites. So we will do a refueling. We use the word as a synonym for bringing artificial intelligence and robotic capabilities into space. So for refueling, you will cut the fill and drain valve. It's existing satellites that haven't been designed for that. You will cut the fill and drain valve, and then you will refuel for lifetime extension. So the vehicle that we are designing is on an all-electrical telecoms platform that is existing. We've just been doing the world record orbit raising with the largest all-electrical telecommunication satellite for Eutelsat. So it's the same platform. And we're just unplugging the comms payload, and we're plugging a robotic service module, if you call it like that. And such a module can do significantly more. You can grab something and bring it somewhere. Now, to be honest, we're not yet at the stage where, from a mission perspective, we have analyzed in detail, would that be a good platform to bring something from LEO into cislunar? What we also investigate is whether we shall not rather upgrade the European Service Module, right? Because the European Service Module is the first and only spacecraft currently that can safely fly to the moon. So if you don't have the capsule, and if you put intelligent into the propulsion system of the European Service Module, you can simply add that robotic service module into the ESM, and maybe that's a better platform to go there. So these are discussions where we're not yet deciding of what we're doing, but we are seeing the need for that, right? Because Axiom is talking about flying away from the space station using their own propulsion probably, but you can also imagine that, you know, if you own a module, you're visiting ISS, you're visiting the Russian, you're visiting the Chinese station, so you need to have something which is doing that transportation service. That's why we rather talk about inter-orbit transportation. And as an engineer, I'm not convinced that we would have one solution for everything, but I think there will be a core architecture around the brain and the capabilities to touch and to safely operate something. Then which platform we are using, it will depend on the mission boundary conditions. And here indeed, of course, from where you go to where you go makes a decisive difference. All right. Thank you.
Good. Then we finally made it to the moon, and this I saw as a kid. I thought, this is great. I might do this, because this is hanging on my wall. This is a calendar of Duff. Duff doesn't exist anymore as a car manufacturer, but this was what the moon was going to look like. And it started well. I saw these cars on the moon. I thought, wow, maybe, you never know, this might happen. But finally we're going there, apparently, and I'd like Claudie to talk about what we're going to do there and how it will look. Thank you very much. Come.
Bonjour. Thank you very much to give me this opportunity to offer to you this thinking about a moon village. So, Back to the Future, I begin with 1957. I think for the majority of us, so the launch of the first Sputnik is an important point 60 years ago. For the other Europe and the European astronaut, the signature of the Rome Treaty in March 57 is also an important time, and that's for me two important stars. Stars, and why 57 are so important for some of us in the room. That's my year of birth, 57. 60 years ago with these two stars. So don't worry, I will not come out as an astrologist. This is up. Just like that. No? Okay. No, just as an astrologist, but I'm deeply convinced that if the future cannot be predicted, the future can be invented. And we need, I would say, a source of inspiration. We need to meet with the right person on the right time slot. And for me it was 69, July 69, and the first landing on the moon. It was this that determined for me my way to participate in this wonderful journey, and I had the chance. As a European astronaut, I would say that's why I choose this picture, maybe with this historical culture of Europe, the exploration to go further, to go beyond. So I know that technically there is a lot of meeting in between the institutional agency in order to define altogether a global roadmap exploration with nice steps. And we discuss a lot about that. We discuss also with all the robotic missions that help preparing the discovery for the future, and this human mission beyond low Earth orbit, with in between low Earth orbit and Mars, the moon, the vicinity of the moon, extended duration crew mission, human to lunar surface. And I do thanks a lot Oliver in his speech just before, because he is a wonderful ambassador of Moon Village, moon surface operation. And it's for me something that we have to take into account. It was one quote from Oscar Wilde that guided my life. Always shoot for the moon. Even if you miss it, you will land among the stars. So that's why when 2 years ago I came back in ESA, and I heard for the first time the Director General of ESA, Jan Werner, explaining his vision of a moon village. For me it was really obvious that moon village is an interesting concept, and I would like to convince you a little bit to take part of this adventure of a village on the moon. So at the beginning I was maybe a little bit alone, promoting with the Director General, Jan Werner, and more, this was an inspiration, attraction for a lot of different communities, the scientific communities, the engineering community, the young people, the young generation, in very exciting talks. And we are not far from. But what does it mean, a village? Village, I think we have to think differently, to think, as I used to say, not just out of the box, but maybe without any box. That's a new concept. That's why it's not always easy to put that in a discussion, an official discussion, a global roadmap exploration or other. A village, that means diverse interests, diverse actors, diverse activities, and diverse calendars. But we have to think about the same thing, a joint understanding. As you will see, it's not a project, it's not a program with a list of requirements, as usually. Even the cooperation scheme is open to discussion. That's an open, inclusive, incremental idea with all the partners from the international community, not just the one from ISS community, but for sure our partners in China, in India, in order to open completely and even to be in the capacity to, for the non-spacefaring nation, to be in a capacity building mindset. For sure, Oliver has said that we will have to define interfaces, to define standard rules, regulation, but it will come later on. The first step is this joint understanding. Diverse interests, science, there is a lot of science to do. A springboard for the private sectors. Yeah, I'm speaking here as not classical partnership in between private and public sectors, but new alliance, new ways to think, coordination with our own contribution, our own calendars, and thinking how we can get together to foster this multidimensional approach in an international cooperation. And that's a wonderful testbed to think differently, to think disruptively for innovation. And I agree on the fact that we have been explorers. I think it's time to become builders and to go from exploration to expansion and development of our humanity. That means, that's true, speaking about a society, and that's the core of a village, thinking all together how we will grow in the future, and thinking also in terms of a lunar economy. And I'm convinced that, as it has been said for the economy in a low Earth orbit, there is also a very interesting element for a lunar economy. Whatever the field, energy, new manufacturing, new materials, mobility, all the environment of tourism, entertainment, or the new services that can be delivered. And for sure, it's an interesting stepping stone for further destination. So I will show you a short video of what can be the contribution of the European Space Agency, because when the Director General Jan Werner came with this idea, he tried to organize a little grouping within ESA between the different directorates in order to put on the table all the ideas to implement Moon Village. So that synthesis emerges, but we can go in this not only imagination, that's for me an utopia, still an utopia, but a realistic one. So you see there, for example, the inflatable that can be put on the surface of the moon. Then, it has been said, we will have to use the resources in situ. So that's an example of using the moon dust, the regolith, in a 3D printing in order to propose a new material to protect against radiation, against the variation of temperature, and the inflatable structure in order to welcome the first crew. The village will be prepared by robotics missions, and then the crew will come, will organize the society, will be mobile. So that's the first glance of what can be the very beginning of a moon village in the mind of the engineers of ESA. So we have already on our papers, and it has been lengthily discussed, element, for example, the Deepspace Gateway. I know I have a trouble with one. Okay. It has been discussed also this agreement with our partners in Roscosmos for the Lunar Resource Lander planned for 2022 in order to develop our scientific and technological program on the Moon. We put a few weeks ago a call for a commercial proposal about ESRI demonstration to produce drinkable water and breathable oxygen by 2025. We are in a phase of preparation of a program jointly with JAXA and with the Canadian Space Agency about lander and ascent system. Why not from the Deep Space Gateway to the lunar surface? And I wanted to show you also what we develop in European Astronaut Center in Portsmouth with the spaceship ESC. That's a network of engineers working on disruptive idea to prepare the future. And we will develop in Portsmouth, in ESC, this analog of a lunar surface, 900 square meters of regularized surface, in order to think about all the operation, habitat that can be envisioned. Simulation, additive manufacturing, I showed you the 3D printing system. So this is a European building blocks, I would say, that can be put on the table in order to think about the implementation of the Moon Village. But there is a lot of idea. We have seen some from China, from India, from the US, and we have already an exciting history. Even this one, I think you have seen that the proposal from Elon Musk in Adelaide a few weeks ago with BFR, to be participant in the Moonbase Alpha. So what I wanted to share with you was the fact that in ESC Adelaide, there was a jam session organized with Jan Werner, where he introduced also this topic of a Moon Village, and saying maybe it's time to put on the table a declaration, a letter of intent, declaration of interest, in order to contribute intellectually, economically, technically, scientifically to this endeavor. So there is a text of this declaration of interest. I will put that on the website. That's just an intent to think about, to make it maybe possible for the future, a desirable and viable way forward to the expansion of exploration. This can be an interesting step in between our permanent presence on the Moon and to go further. This is the site in ESA where you can get all the information, get the declaration of interest, send your approval, your signature, and this letter of intent, the Moon Village at ESA.ent. And then I will just give you as an information, because I think it's not purely something that is related to agencies or to the industry side. Some non-governmental associations are interested in the fact to be promoters, to be ambassadors, to be bridgers, and this is one. The Moon Village Association has been created a few weeks ago with this mission statement, a forum for the development of the Moon Village. So the Moon Village Association will organize a workshop in November in Strasbourg, international as much as possible, a kind of market exchange. You will propose things, or you will receive, you will discuss. It's an open forum. And I give you also their specific site, the moonvillageassociation.org. So it was just to introduce to you this topic of the Moon Village. I think next year, and 1 year from now, if we may have an addition around this idea as a test bed for innovative idea. And maybe in Bremen, for Oliver in the next IAC, or maybe in our next meeting of the Association of Space Explorers, we can go further in the definition, the implementation. And I still have a dream. I think 2019 would be an important time to have an international commitment for Moon Village, towards the Moon Village. 2019, that means 50 years after the first landing in the moon. Thank you.
Some questions still, or is it all clear?
It's completely open, so your question, I do prefer element to concretize some element. The question, everything is open, so we have to think all together.
Questions later. Okay, thank you very much.
Thank you.
Okay, thank you. This was the end of the technical sessions, and now we have to do something. I would like to ask Andy if you have time for some important messages. Please listen carefully, because there are some things that you have to do before you can start with the tour.